Hello everyone, my name is Nilma. Today I am going to explain about signals approximation. This presentation delves into the concept of approximating signals using orthogonal signals, and it highlights the crucial role of mean square error in assessing the effectiveness of these approximations, providing insights into how well the approximated signals represent the original ones. We start our topic from introduction, that is basic definitions of signals, which are signals are the functions that convey information, typically varying with time or space, and can be analog or digital in nature. And there are two types of signals that can be one continuous and discrete signals, both of which can represent various physical phenomena such as sound, light, and data. And the importance of signals in communication is very crucial in communication systems where they are transmitted, processed, and analyzed for effective information exchange. Orthogonal signals. Here are the basic definition and properties where orthogonal signals are a set of signals that are mutually perpendicular in a vector space, yielding an inner product of zero. And the applications of orthogonal signals are widely used in communication systems such as orthogonal frequency division, multiplexing. And the benefits of signal processing are it reduces interference and improves clarity, enhancing signal recovery in noisy environments. Mean square error. Here is the basic definition of mean square error. Mean square error is a measure used to assess the quality of an estimator or the accuracy of an approximation, which can be defined as the average of the squares of the errors between the estimated and actual values. And we can calculate the mean square error by taking the average of the squares of all the errors and providing a clear quantifiable metric for evaluating signal approximation. And the formula for mean square error can be given by mean square is equal to 1 by n into summation of true signal minus estimated signal whole square. And the significance in signal processing is it is a lower mean square error indicates a more accurate approximation, making it a critical criterion in selecting the best signal representation approach. And here is the basic simple example on mean square error. To understand mean square error in context of signals and systems, we consider the following example, which is we can assume a true signal, which can be mathematically represented as S of t is equal to sine t. And the estimated signal can be represented as E of t is equal to 0.8 into sine t plus 0.1, which has some error. And we can calculate the mean square error by using the formula 1 by n summation of S of t minus E of t, where we are assumed by representing mathematically whole square. This example illustrates how different approximations affect the quality of signal representation, setting the stage for the next discussion on orthogonal signals and their reduction of mean square error. Orthogonal signals and mean square error. In the definition of orthogonal signals, the signals are orthogonal if their inner product is zero. We can simply say this definition. And the impact on mean square error of orthogonal signals or orthogonal signals minimize mean square error by avoiding interference and the applications which can be used in communication systems to enhance signal clarity. And the basic mathematical representation it can be expressed as E of x1 into x2 equal to 0, where for orthogonal signals x1 and x2. There are many signal approximation techniques, and some of them are discussed here. And one of it is projection method, which means which is one of the most popular technique involves projecting the signal onto the space spanned by orthogonal basis functions, which helps in generating efficient approximations. And another technique is here, which is linear combinations, where signals can be approximated using linear combinations of orthogonal signals, leveraging their properties to ensure minimal overlap and error. And also another technique is wavelet transforms, which is an advanced method such as wavelet transforms utilize orthogonal wavelet basis for multi-resolution analysis, further decreasing the approximation errors. Here is the case study on signal reconstruction. And the real world application is it is a case study on signal reconstruction, which demonstrates how applying orthogonal signals significantly improves the reconstruction quality while maintaining a low mean square error. And the results are overview can be showed a substantial decrease in mean square error when using orthogonal approximations compared to traditional methods, highlighting their effectiveness. And implications for future research. This case further opens avenues for research into other applications and adaptations of orthogonal approximation across various fields. We thoroughly often face some challenges in signal approximation. Some of them are computational complexity, which is a high computational requirements can be a barrier requiring sophisticated algorithms for practical implementation. And most frequently face a challenge is noise sensitivity, which means it is a signal approximation can be sensitive to noise, leading to increased mean square error of not managed properly. And selection of basis functions. Choosing the most suitable orthogonal basis function is critical and impacts the quality of signal approximation. Future directions in signal processing. In improved algorithms, there is an ongoing need for developing more efficient algorithms that can handle increasingly complex signals while maintaining low mean square error. And also, we can see further development in integration with machine learning, which means by incorporating machine learning techniques for dynamic selection of orthogonal bases in real-time applications, promises enhanced signal processing outcomes and extensions to non-orthogonal signals can be future research can explore the adaptation of the concepts to non-orthogonal signal spaces to uncover new approaches to signal approximation. And the conclusion of orthogonal signals and mean square error is here. And today in our topic, we discussed about orthogonal signals and mean square error. And some of the key points are here, which is the representation demonstrated the critical role orthogonal signals play in the approximation process and the importance of mean square error as a measure of efficiency and the impact on signal processing. The integration of orthogonal signals and mean square error has far-reaching implications for improving the quality of various signal processing applications. And finally, the call for continued research, which means the ongoing advancements in the field will require continuous research and exploration of innovative approaches to signal approximation. Here, some of the signal processing references where, where are important books on signal processing. A selection of comprehensive texts that delve deeply into both the fundamental theories and practical applications of signal processing. Also, can explore into cutting-edge research papers in signal processing, where we find an overview of current methodologies and the latest innovations that are shaping the future landscape of signal processing. And we can also get valuable online resources for learning and networking, where we can get a curated list of websites and forums that provide continuous learning opportunities, resources, and community supported in the field. Thank you.